Hey there, YouTubers, Pythonistas, School of Tomorrow students, design scientists. This is going to be pretty technical, but in different areas. So I'm going to dive deep into Python a little bit in continuity with the last episode, which was a 20-minute deep dive into some Python. I'm going to touch on that kind of in follow-up. And then we're going to do grid talk. Grid talk, what do I mean? Well, if you go back to some of my Codesters episodes, I'm showing how what apparently, on the face of it, just kid-minded software called Codesters. It's not really, yes, it is software, but it's a sandbox where you develop skills, you work out, and learn the skills of tomorrow in the school of tomorrow, using the calculator of tomorrow, you could say. So in this one, let's see, sometimes I have to go back and actually look at the source code myself to figure out what's going on. Something about click tells me that the stage, which is on the right, is listening for click events. So, okay, so that's what I mean by grid, right? Now this shows some interties that maybe don't exist, and this is really Germany-centric, even though I call it European. But it gives you the idea of what I'm talking about. And here's Asian plan, and that's a good segue into, I'll postpone the Python 2 later and dive into, that's where we were yesterday. I'm building this logo in higher resolution from geometry, from first principles, from quadrays, by way of a ray tracer called POV ray. Okay, so these kind of technical skills are going to carry over when I talk now about this presentation I was at last night at a Thirsters gathering. We meet in one of the McMinimans, which is what you're seeing there, a beautiful restaurant bar on a second floor on the east side of Portland. And a lot of these people were in the Peace Corps at one time, but you know, who's there on any given night? I'm rarely there myself in this room, and that's Alan about to give his presentation, and Barbara you may recognize from Wanderers, because just a few slides ago, in fact, let's go for continuity again. Let's go to the Linus Pauling House, which is here in the quote-unquote asylum district. So here's some of the POV ray masterpieces, not all by me, by the way. Like, I can get a POV file from Adrian's anti-prism, and so there's Barbara there too, right? So there's a lot of overlap between these different little Portland's a kind of a small town, you could say. So I'll go through these very quickly, these shots of a fairly dim screen that I wouldn't expect you to be able to read, but Alan is following the story of one of the world's largest, most important rivers, which drains from what we would call China through what we would call Thailand, Burma, and you know, it's a very important river, but so far it has not been hydrologically dammed. It doesn't have power dams on it, and there's a lot of schemes and thoughts about what to do and where to put dams and stuff. And Alan, having an ecologist mindset, kind of like my dad was a regional planner, we're interested in not just oil pipelines and stuff. A lot of the newspapers, they sound like people on the Titanic. All they ever talk about is Victorian stuff, like oil, you know. BP, give us a break, right? We're living in the 21st century. Sometimes we'd prefer to chat about electrical grids and not make it all scary, where New York Times has to say, oh, you might, you know, be a Russian bot or something. No, it's just normal to think about infrastructure. We all played SimCity as a kid, see? That's the thing. We're all hip to these things and could use some better simulations. So Salween Peace Park is being dedicated here. Alan's telling us all the politics involved. As usual, indigenous people are not that thrilled by some idiot European nation-state philosophy with their quote-unquote central governments and all that garbage, right? But you kind of have to believe it because they have guns and they'll shoot you if you don't. So, but when it looks like you might be able to get back to smarter land management. You know, it's sometimes tempting to think that's possible, and so, you know, I don't blame the people who've been around the longest with their cultures for wanting to hold on to some of what they had. It's not my place to get in their way necessarily. And on that theme, pickaxe. So when I came home from that presentation, my house guest had been involved in some forest activism recently, and this is not recent. Like this stuff about Cascadia Free State story, this is just part of our history now. This is like 20 years old now, the stockade and all this standoff, and it was during the Clinton years, right? So I watched this movie for the first time. It's been up there since May 9th, 2012, and here we are in 2019. So thank you, Alan, for that interesting presentation. Diving now into some of the technical Python bits. Where I left it was I was kind of frustrated in needing to subclass my QRays vector, that my QRays Q vector, right? That's this guy. I had to subclass it because I wanted to carry the weight now of how thick is my rods and how, and you might be thinking, you know, I said earlier I don't use the vectors directly to show. I use edges, and edges are vector pairs, so why not put the weight on the edge class to colorize and think about radius and just leave the Q vector alone. And that might be good. That might be good advice. However, in the background, there's also VPython lurking, and I'm kind of thinking I'm doing a double duty here. I'm kind of creating a model for where I do want to render the vectors as well, not in POV-Ray maybe, but in VPython. The thing about Alan's stuff, by the way, is he's got this website, but he doesn't really express his stuff in terms of websites. He's more thinking in terms of PDFs, which is an interesting push on the technology, right? He puts all this, what he's showing as we're projecting here in the McMinimans is the content of various PDFs, which include movies and all kinds of things, right? There's stuff that MPlayer might read. There's hyperlinks. So a lot of us, when we think PDF, we basically just think like a Word document, but more portable, because PDF stands for Portable Document Format. But what Adobe built into that format that hardly anyone uses is a complex API. I won't say complex, actually, because Alan's contention is even PhDs who don't know HTML can do this, whereas supposedly some IS people have to take over when the web's involved. Now that's kind of more European kind of thinking that we don't necessarily buy around here, but I understand what he's saying. So here's the giant version of the 4D logo that I am generating using this Python. So that's my motivation, is to get all this bright colors and shadows, and, you know, the thickness of these cylinders matters now. But when we are more in the platonic space of the Q vector, that's just a plain old vector with a few wrinkles, and we don't have any comprehension of what we would call secondary characteristics, which would be like, you know, what color are you? You don't think of that as being a primary characteristic of a platonic. I say, here's a tetrahedron. Think of a tetrahedron. It's like, teacher, what color is it? And the teacher's like, well, we don't care. It doesn't matter. Color is like irrelevant. Stuff like that. But that's not irrelevant in the world of ray tracing. It's very relevant. So we've got to bring it in. So my notion is just subclass the platonic vector and add these secondary characteristics, make it more of an empirical vector that knows things about radius and stuff. But was that going to require me to then do little wrapper methods for adding and everything? Because the tendency when you do things like this is for an operation to drop you down into the parent type when you add two Q vectors or scale it. So here's the problem I was having over here on the right now. I'm creating a Q vector of the new kind, the one we're looking at, this type here, starting on line 29, And that's cool, but then I add two of them together, and you can add vectors, as you know, and I look at the type of 2A, and this is not the same type now. This is Q raised vector, i.e. the parent vector. And the parent Q raised vector, actually I'm highlighting the wrong thing, the Q raised Q vector is the parent. And it's so far, it doesn't know anything about, we're back to not knowing about radius and color. So we've lost the type we were using. And I had a way of wrapping negation as an illustration of how I could salvage the situation by creating a overriding a method for negating. But if I was going to have to do that for adding and multiplying and so on, that'd be a problem. So here's the change to make. Here's what saves the day. Back to Q raise, which I wasn't going to change, at least not without good reason. Going down to the Q vector class, what I can do when I do something like scale or add or multiply a vector. So that's what these double underlined quote-unquote ribs are about. The ribs of the snake, of the python, you could say. How does my nervous system respond when you ask me to multiply a vector by a scalar? Well, it did return another Q vector by name. It did say Q vector right here. And every place that I would return a Q vector by name, I would instead now return, because it'll find the wrong one in that case. It'll return the Q raised Q vector if I do it that way. But if I say, get the type of your current self, whoever you are, and use that to create this thing with the new coordinates, then we'll stay in the space of the new Q vectors. In other words, adding, subtracting, which just refers to adding, and so forth, even cross product, are now going to be sensitive to, and the only way we can, by the way, multiply Q vectors is to scale them. There is no multiplication of two Q vectors with each other like we can do in complex numbers. Complex numbers are another thing. Now, we can talk about if we wanted to steal that method from the complex numbers and have the same thing go on in the ordinary XY plane. We could even steal the quaternion stuff, but we'll talk about that some other time. Right now, I've got a solution that I like, and I will check this into my repo on GitHub, because this is generically useful for people who want to do some subclassing on their own. And I don't know what the fate of all of this code is going to be yet. I think it's too volatile to be worth trying to integrate into a shared curriculum at this point. Rather, just make the YouTubes and acquaint you with the process of Python development. This is what it looks like. If you watch the last video, you'll see what I was doing with the property decorator and some of that other stuff. So again, these things all connect in terms of what my curriculum focuses on, given we're going to Bucky Fuller a lot, American Transcendentalist, humanities, philosopher type, with a lot of street cred in other disciplines, especially architecture, but not only architecture. Here in the planning world, which I'm sort of in right now, where Alan lives and where my dad was professional, we talk about things like grids and all that. So that was the world game aspect of Fuller's thinking, which I've talked about at length in other videos. So we'll see you soon. Onwards.